Hi, and welcome to Complex Numbers Day 3. Today we're going to talk about complex numbers as vectors. And that just means simply we're going to be putting complex numbers in the coordinate plane. And a complex number is graphed as xy, and it's in the form x plus yi. We talked about it the other day as a plus b. Okay, a plus bi form. Same thing as x plus yi. To write complex numbers as vectors, plot the point and draw a straight arrow from the origin to the point. So what that means is if we have the point 3 plus 4i, we would graph it as the point 3, 4, which is right here. And then we start at the origin and we draw a straight line out and put an arrow on the end. So that's how you graph a complex number. 2 minus 3i is down here. This is quadrant 1, remember, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So if we go back and we look at 2 minus 3i over 2 down 3, there's a point 2, negative 3, that puts me in quadrant 4. And then if I have the point negative 4 plus 2i, it would be negative 4 positive 2, puts me in quadrant 2 right here. And then I have 3, which would really be the same thing as saying 3 plus 0i, because the 0i isn't there. So that becomes 3, 0, which is right here on the x-axis. And then 4i would just be 0 plus 4i, which is right here on the y-axis. So write the following as either complex numbers or ordered pairs and tell which quadrant they are in. So we have 5 plus 6i, which we would just simply write as 5, 6. And that would be in quadrant 1. Negative 2 minus, or sorry, negative 3 minus 2i is the point negative 3, negative 2. And that would put me in quadrant 3. Negative 5 is negative 5, 0, and that's not in a quadrant. Two minus 12i, sorry, 2 minus 12, which would become 2 minus 12i, and that would be in quadrant 4. And 0, negative 3 is just the number 3i, and again, that's not in a quadrant, so it's a none. All right, moving on. We are going to review adding and subtracting complex numbers. To add complex numbers, simply add each like term. So we have 3 plus 4i plus negative 4 plus 2i. We can take and rewrite it this way. And we have 4i plus 2i is just 6i, and 3 minus 4i. All we're doing is combining like terms. Subtracting complex is similar. However, you must treat the complex number as if it were the polynomial and taking the additive inverse of the term you are subtracting. Follow the example. So we have to subtract 3 plus 4i from negative 2 plus 2i. Notice the from is the first one. From comes first, in case you don't remember. So taking the additive inverse is simply meaning we distribute the negative sign inside. So now I have a 2i minus 4i, which is negative 2i, and a negative 2 and a negative 3, which is negative 5. Add or subtract the vectors. Here, since it's positive, I can simply ignore the parentheses, or I can just rewrite it as 10 plus 6i minus 4 plus I, Combine like terms, 10 and negative 4 is 6. And 6i and I is 7i. So 6 plus 7i is my final answer. Again, I don't have to worry about my parentheses there. So it's 4 plus 3i plus 5. So 4 plus 5 is 9. And there's nothing to combine with the 3i. So we just leave it as 9 plus 3i. Now here I need to distribute my negative. So I have negative 3 plus 2i minus 2 plus 6i. So negative 3 and negative 2 is negative 5, 2i, and 6i is plus 8i. So negative 5 plus 8i. For number 4, I have 4i and distribute my negative. So 4i minus 1 minus 7i. So I have nothing to combine with the negative 1, so it's negative 1. And I have a 4i and a negative 7i, so I have minus 3i. The whole number, remember, always has to go first. The complex number, I, always has to come second. All right, moving on. Multiplying complex numbers. When you're multiplying complex numbers, it's the same as multiplying two polynomials, so you're going to have to use FOIL or double distribution. And remember that I squared is equal to negative 1. That is huge. Okay, there is an example done for you. You can look at it on your paper. I'm just going to get right to multiplying. 4 times 3 is 12. 4 times 5i is plus 20i. Negative 3i times 9 is negative 9i. Negative 3i times 5i is negative 15i squared. Remember, I squared is negative 1. So I end up with a 12, and then this becomes plus 15. So it becomes 27. And then 20i minus 9i is plus 11i. Here we're just distributing one time, so it becomes 4i times 6 is 24i, and then it becomes minus 8i squared. I squared is negative 1, so this becomes plus 8, so I end up with 8 plus 24i. Alright, this is the new part. We have identities and inverses. For real numbers, the additive identity is 0. So for example, 3 plus 0 equals 3. Basically, with an identity, we're looking to get 0 we're looking to get the same answer that we started with. So the additive inverse of a number is its opposite, or when it's added, the result is 0. So example there is 3 plus negative 3. So when we're trying to find the inverse, we want the negation. We're trying to find the identity of addition is always 0. So for complex numbers, the additive identity is 0 plus 0i. So to find the additive inverse, we must find a complex number. When added, the result is 0 plus 0i. So find the additive inverse of 3 plus 2i. What would we have to do to get 0? So you'd have to negate both things on the top. You'd get negative 3 minus 2i. So find the additive inverse for the following. Just negate both terms. So we have negative 7 plus 6i. For number 2, negate both. I have 4 minus 3i. And for number 3, again, negate both. 5 plus 4i. For real numbers, the multiplicative identity is 1. For example, 4 times 1 is 4. The multiplicative inverse of a number is the reciprocal. So 4 times 1/4 is equal to 1. For complex numbers, the multiplicative identity is also 1. Find the multiplicative inverse begins the same way as with real numbers, but you must rationalize the denominator the same way you would if the radical was in the denominator. So, find the multiplicative inverse of 3 plus 2i. So 3 plus 2i times what is equal to 1? Well, this is what would go in place of my question mark. But this is not a complex number. It must be rationalized because you can't have an I in the denominator. So I multiply by the conjugate again. And the conjugate, we only change the middle sign. And the numerator, I just get my conjugate. And by denominator, remember, we're multiplying, get the first and the last. So 9, and then I end up with a minus 4i squared. I squared is negative 1. So that becomes plus 4. So I have 13 in the denominator. And you can break it up into two parts. A plus bi form is technically this here, because you've broken it into two terms. So the multiplicative inverse of 3 plus 2i is 3/13 minus 2/13 I. This can be confirmed by multiplying and obtaining a result of 1. So for number 1, find the multiplicative inverse of the following complex numbers. So what we need to do here is multiply by well, first find the reciprocal. So it's 1 over 4 plus I. Then multiply by the conjugate, so it's 4 minus I. So on the top, I get 4 minus I over, on the bottom, 4 times 4 is 16, and then I times negative I is minus I squared. But I squared is negative 1, and then that makes plus 1. So it becomes 4 minus I over 17, and we just break it into our two fractions. So 4 over 17 minus I over 17. For number 2, write your reciprocal. 1 over 2 minus 3i. Multiply by your conjugate, so 2 plus 3i. So my numerator stays 2 plus 3i over my denominator. Just multiply your first and last. I will have 4 minus 9i squared. I squared is negative 1. Those two make plus 9. So it's 2 plus 3i over 13. And then just break it into its parts. So 2/13 plus 3i over 13. Last one here. 1 over 5 plus 5i, because that's my reciprocal. And then multiply by the conjugate, which is 5 minus 5i. The numerator is not going to change. It is 5 minus 5i over 5 times 5 is 25. 5i times a negative 5i is negative 25i squared. I squared is negative 1. This becomes plus 25. So it's 5 minus 5i over 50. They all have a 5 in common, so we need to reduce that. So it becomes 1 minus I over 10, which is 1/10 minus I over 10. All right, that is it for today.